while I introduce today's speakers and topic. So the purpose of this third session is to introduce concepts in environmental and resource economics to first address central questions in managing coastal resources as natural capital that depend on feedbacks between human decisions and geophysical processes. And second, to introduce the role of housing markets in reflecting the value or cost of coastal amenities in response to the changing environment. And so remember, the idea behind these Disciplines 101 seminars is to really get down to the basics behind and the basic concepts behind the disciplines that really contribute to understanding coastal dynamics and the evolution of the coastal system. And today our speakers are Satya Gopalakrishnan, Professor of Economics at The Ohio State University, and Marty Smith, who's a Professor of Economics at Duke University. Just a reminder that as we have been doing for the previous seminars, that there will be a 10-minute break between speakers for a Q&A. And we're asking that you please submit questions within the chat, which is activated this time. And if you submit them to the chat, Catherine Anardi, our project manager, will moderate. And we're going to try to be more interactive this time with the Q&A. So if possible, Catherine will call on you, and if possible, please unmute to ask your question. We're hoping that we can go ahead and have questions more directly from those of you who are here and who have submitted questions. So submit questions to the chat, and Catherine will organize them into an order like she's been doing so expertly, and then please unmute to ask if called upon. If you prefer for Catherine to ask, you could note that too. All right, I'll turn it over to Marty, who will be starting us off.
Thanks, Laura. Welcome, everyone. And today I'm going to talk about three themes in natural resource economics and how they relate to coastal resources. And I'll focus more heavily on two of those themes and then give some examples that are drawn from my work on fisheries and also from my work on beaches. So let's jump right in. The first theme I want to talk about is one that's more about just something that should be obvious to everyone, but isn't necessarily always obvious. And so I want to make this point clear at the beginning, that resource scarcity is actually an economic phenomenon. It's not simply a biophysical one. Many people would ask, oh, if you want to know, are we running out of oil? Ask a geologist. Well, of course, a geologist would have something to say about whether we're running out of oil. Similarly, are we running out of water, freshwater resources? Well, ask a hydrologist. Yes, absolutely, a hydrologist would have something to say. But these are economic phenomena in the sense that running out of oil doesn't necessarily mean is the tank completely empty. It's really about how much can we get given our existing technology and what's actually affordable to recover. So economics are a part of that problem. And similarly with water, there's a lot of salt water in the world that we could desalinate for an extraordinarily high cost. So that's an economic phenomenon to say, are we running out of fresh water resources, and not purely a hydrologic one. And if we think about sand on beaches, we might want to rebuild beaches that have eroded. There's a lot of sand out there. And what's recoverable in an economic manner is much more the issue as opposed to how much total sand is out there, because there's a lot of sand sitting in the Sahara. But I really want to focus more on these other two themes. And the first one is natural resources are a form of capital. And Laura already mentioned this in the introduction. What do we mean by that? First of all, dynamics or changes over time are important. So just like financial capital, like money that might be sitting in a bank account, or human-made physical capital, like the machines that produce things, the dynamics over time are really important. And we distinguish between stocks and flows. So we talk about the stock of capital, how many machines you have, or how many fish there are in the ocean, or how much sand there is, and the flows, the changes over time. That's investment in capital, extraction of resources, or depreciation of capital, something that could be true of human-made capital as well as natural capital. And this is the key point that we're going to talk in more detail about in just a second, the optimal use of capital is when we equate the rates of return on financial and natural capital. So I'll go through that in a lot of detail in a bit. And then the third theme is that institutions affect the patterns of exploitation of natural resources and the value that they generate. And what I mean by institutions is the rules that apply to how resources are actually taken. So those might be formal rules like regulations, government regulations. They may be formal rules like property rights. Someone or some group or some firm owns a property. Or they may be informal things like groups of people that have informal rules for how they govern them. But the institutions affect those patterns of exploitation. Has someone turned on the, it looks like someone has turned on a mark there. Can someone clear the, no, I don't know where that came from. It looks like someone's turned on annotate.
Yeah, Marty, why don't you go to the top of your screen?
Yeah, and clear.
Annotate. Yeah, and clear it.
Yeah, let's see, erase. I'm clicking on the eraser. I can manually do it. Okay.
Awesome, thanks.
All right, so let's proceed with natural resources as capital. And again, I'm going to say this repeatedly. Optimal use occurs when we equate the rates of return on financial and natural capital. So everyone's heard the expression, time is money. And the traditional expression really is about, well, I get paid to work and I earn money on a wage, you know, I earn a wage for that. So if I take time to do something that's not working, I'm actually giving up money. I'm giving up a wage that I could be earning. In other words, there's an opportunity cost of spending time in some other manner besides working. So the idea of time and an opportunity cost, it goes the other way as well. If I am working and I'm earning a wage, well, my opportunity cost is also that I could be spending that time with my family. I could be spending that time on vacation or reading a book that I like. And that might have value that exceeds the wage that I'm earning. So this connection between time and money and this idea of opportunity cost is a very general one. But we can also think about, what do we do with money that we've saved? We can put money in a mattress for 10 years, or we could put money in a bank account and earn interest, or we could invest it in the stock market. So there's an opportunity cost associated with putting money in our mattress, and that would be the money that we would have earned had we put it into a bank account or had we put it into a stock market. Now, if I gave you this choice, you might think this is insulting for an economist to think that non-economists wouldn't know how to answer this question. Which bank would you prefer to invest in? The bank on the bank that pays 10% interest, or the bank that pays 5% interest? If there's no other differences, they're identical banks, and one is literally just paying 10% and the other is paying 5%. It doesn't take a PhD economist to recommend to you that you should put your money in the bank that pays you 10%. That should go without saying. And if we were to stop there, you might say it's a little insulting for me to tell you that. What I want to emphasize, however, is that the same intuitive reasoning for why you would pick the bank that pays 10% over the bank that pays 5% is the key to understanding how we balance investments in natural capital versus financial capital. Which one is actually paying the higher rate of return? So if instead of investing in two different banks was the choice, you had the choice to invest your money in a bank in financial capital or invest your money in the stock of fish, then you would be asking the question, which of those investments pays a higher rate of return. And that's precisely how you answered the question previously. So kind of thinking through the intuition of this, what are the heuristics? Well, if the rate of return on the financial capital is higher, I'd invest more there. If the rate of return on the natural capital is higher, I'd invest more there. Simple so far. Only when the two rates of return are equal are you doing the best you can do. Now, some of you might be wondering, well, how could that be? Because aren't those rates just given? And the answer is, if you're choosing to invest in a bank, they're going to tell you what the interest rate is. And from your point of view as an investor, yeah, that rate is given. So you can think of as a consumer, as an individual firm, or even as a whole community, you can think of the rate of return on the financial capital is something that's given to you. But what's not given is the rate of return on the natural capital. In fact, what's critical here is that when you liquidate or accumulate more natural capital, you actually change the rate of return. And this is most readily illustrated by a stock of fish. For many models of population dynamics, the rate of return on the natural capital, the stock of fish, is actually declining as the stock of fish gets larger and larger and larger. So if you're interested in equating your rate of return on financial capital with your rate of return on the stock of fish, depending on where you hold that stock of fish, at a high population level or a lower population level, you are affecting the rate of return on that stock of fish. And if you're going to get 5% rate of return on your financial capital, you would equate this rate of return at something like a little more than 0.4 of the carrying capacity of fish. Now that's a very simplified, stylized version of this, but that's the heuristic for how to think about this. Now the real world, of course, is a lot more complicated, but let me just provide you a quick application to some of my work on fisheries. This is based on work on the North Carolina shrimp fishery published in the American Economic Review. And the idea here is that the way the current system works, we're investing too little in the stock of shrimp early in the season. In other words, people are catching too many shrimp early in the season and too few shrimp late in the season. And the reason that's too many early and too few late is that the rate of return is actually higher if you wait a little bit longer and allow the shrimp to grow larger, because the shrimp are actually worth more on a pound for pound basis when they're larger. So the policy that we should implement in order to increase our rate of return on the natural capital and actually bring that rate of return in alignment with the rate of return on financial capital is to decrease the number of vessels fishing early in the season, and then to compensate for that by increasing the number of vessels fishing later in the season. Now, again, there's a lot of bells and whistles and complications in how we end up arriving at this result, but the heuristic idea of which of these banks should I invest in is actually operating on why this policy actually increases returns for the fishery. We can think also about the optimal timing of beach nourishment as an application of this same phenomenon. And again, like we talked about 2 weeks, or in the first session in positive and normative modeling, we certainly don't want to claim that beach nourishment is an optimal policy, but considering from the point of view of the community, a community that's doing this policy anyway, we might think about how to time that nourishment in order to do the best they can with respect to their rate of return. So this is a picture of before and after nourishment at Nag's Head. So we've developed modeling of this, and to figure out the optimal rotation length of beach nourishment on the basis of the rates of return of financial capital and the rate of return that you would be getting on the natural capital which in this case is actually the width of the beach that's available for protecting against storms and available for recreating. And that value of recreation in turn gets capitalized into home values. So the way to think about this, this model set up in this simple state equation that's written here, this is actually a very, very stylized characterization of some of the geomorphology that Brad Murray talked about 2 weeks ago, where there's some erosion associated with a longshore sediment transport. And this term here is referring to this idea that when we nourish a beach, we basically create a bump, and that will generate some, in a diffusive wave climate, some return to equilibrium profile. So there will be a tendency for waves to smooth that bump out. And that's basically what's involved in this equation here. And then we are linking that via a benefits function to the choice of when best to nourish. And in this benefits function, we have things like the value of the property, and then we have things like delta. That's our rate of return on financial capital that's going to come into play. And that's also going to turn the stock, the value of the stock of the resource, into a flow that we add up over time. And then we have this parameter here, that is actually a parameter on how valuable is having additional width of the beach. And Satya, in her talk, will talk more about how to empirically study this in the context of real estate markets. But what does this generally look like? You see the width of the beach is going to decline over time, and then you're going to re-nourish, and it'll increase again, and then decline, re-nourish, decline, and so forth. And some fairly intuitive things pop out of a model like this. And I won't show all of them to you, but one is simply that as the value of beach width increases, you are going to nourish the beach more often. So these are contour plots of the rotation length. So you can see at a higher value of beach width for a given financial rate of return, at a higher value, you're going to nourish here at 4-year intervals as opposed to here at 5-year intervals at a lower value. So the second, or the other theme that I wanted to talk about today is that institutions affect the patterns of exploitation of natural resources and the value that they generate. And remember, institutions, again, the rules that govern that exploitation, including formal institutions like regulation and property rights. So here's another case from a fishery example. This is one in which there were 3 periods where the institutions governing this fishery changed quite dramatically. In the first phase, the open access phase, there effectively was no management whatsoever. This was a free-for-all that was generating a boom and bust and what most people would consider to be a collapse of this fish stock. This is the landings of Norwegian herring. The second phase is one in which there was restrictions on access to the resource, but no formal property rights. And the third phase is one where they established formal property rights to the resource. Now, what is it that's going on with the red and the blue? In the blue, that is actually the disposition of the resource for human consumption. So these are herring that then go into markets where people are eating them. The red is herring that's going into a much lower value use, an industrial use, basically grinding it up to use the oil for feed, for other industries, for livestock industries, for aquaculture, and grinding up the flesh of the fish to fertilize fields and so forth. And that's a lower value use. And what you saw is that that was the dominant use in the institutions under open access. But when they began to rebuild the stock of fish, that dominant use of the low value started to happen again. And it was only when they transitioned to a different institution where they were able to rebuild the stock of fish and the dominant use became the higher value use for human consumption. We see another phenomenon in which the institutions really matter in other work that I've done on catch shares, where they take the total allowable catch of a fish and they divide it up among the participants in the industry. And those individual firms or individual fishing vessels have a guaranteed right to catch a certain share of the allowable catch that biologists have determined is a sustainable catch level. So we studied this transition to this to see how does that affect the behavior of people in the fishery. Because one of the phenomena in fisheries that is common is a race to fish. People try to get out there and catch the fish before the other guy, and that leads to all kinds of problems, including overfishing, lots of accidents at sea, and generally lower quality product that comes out. And what we found is that this transition to catch shares, where people had a guaranteed right of access, even without any changes in the allowable total catch for the industry, actually spread the season out. So this is just a picture of aggregating all Gulf of Mexico fisheries together. We actually did this on 39 fisheries in the United States with matched controls. And this is an illustration of some of the individual results that came out. So these are showing basically that this policy spread the season out. And here's another application, but to beaches this time. The standard way that we have, the standard institutional arrangement that governs access, or that governs beach management, is that local communities make these decisions. Now, of course, there's complications there and there's interactions with the Army Corps of Engineers. When we think about the actual decisions on the ground, it's local communities are getting to make these decisions in a decentralized way. And we have shown here that the decentralized management actually ends up underinvesting in the width of the beach. So kind of again, tying back to the talk 2 weeks ago, bumps tend to get smoothed out, but if you situate two communities next to each other and one is nourishing its beach or sticking out further, this bump creates a gradient between these two communities. And as a result of that, this community here that's further inshore, this community has an incentive to not do as much to widen its beach because it's going to be the recipient of some gradient from the beach here. Whereas this other community that's sticking out has an attenuated incentive to nourish its beach because it's going to lose some of it due to being a bump that's sticking out and this diffusive process. So the result is when these communities don't coordinate in decentralized management, you end up with a beach width that's narrower than in a world in which these communities here are actually coordinating. So that's yet another example of how institutions are affecting the actual outcomes, that the resource exploitation or the resource usage, as well as the value that's generating from those. Okay, so to summarize this, we're going to come back to our first session and reflect on the positive and normative again. So optimal use of a natural resource occurs when the rate of return on the natural capital is equal to the rate of return of financial capital. Now, this is a normative theory. This is basically predicated on the idea that we're trying to maximize our total returns from the natural capital. It can be a positive or predictive model about how communities actually behave. So Satya is going to illustrate that in her talk as well to show that this model of rotational management actually, if you calibrate it and estimate the parameters of that model for different communities, it predicts how often communities nourish their beaches actually quite well. The notion that institutions affect the patterns of exploitation of natural resources and the values they generate, that I would say is generally in the realm of positive theory. However, it has important normative implications because predictions are often relative to some normative objective. So which values actually matter? Does it matter that we're racing to fish? Does it matter that we generate more economic value from the same stock of fish? Does it matter that communities are generating more economic value from widening their beaches? If those are the things that matter, that you can't avoid that we've infused some normative content into studying studying these problems from a positive lens or a predictive lens on what's happening. So thank you all for listening. These are the references, and I think all these slides will also be available online, and I will take questions.
Okay, thanks, Marty. We have our first question in the chat is from Reed. Reed, can you unmute yourself and...
I can.
Cool.
Am I unmuted?
Yes, you're
Hey,
good.
Marty. Thanks. I appreciate it. Great talk. Not being an economist, I appreciate the 5 versus 10%. And so I know where to go bank now. So one of the things when you showed that example from fish stocks and the rate of return versus the stock itself, that model in itself would suggest that fishers would want low fish stocks, right? Because they would get better rate of return generally.
Yeah.
But so I'm curious, two things. Well,
Yeah.
First of all, I guess institutions wouldn't allow that to happen. And secondly is how do you take into account, or is it taken into account the effort, the fishing effort needed to catch in that rate of return?
Yeah, Reed, that's a fantastic question. So, of course, that's a very, very stylized model in which we've kind of assumed away some of the important features. So if all that people cared about was the rate of return on the basis of the population dynamics, then in fact, the populations, they turn over faster at lower total populations. And so there would be an incentive to maintain a low stock. But of course, that's not all that matters, because if you're actually in the business of fishing, most of the time it's easier to go out and find fish to catch them if the stocks are bigger. So that incentive actually tugs the optimal stock in the opposite direction. And so if you account for that, that folds into what that rate of return on the natural capital actually would be. So that's, that again, that's a very, that picture I showed you was one that assumes that away. Gotcha. The application to the shrimp that I showed you takes all of that into account. Gotcha. The other question that you raised was, do institutions even allow this? And the answer is, generally, the institutions won't allow you to purposefully knock the stock below the amount that would generate the maximum sustainable yield. However, the institutions will allow you to be more conservationist than that if it's warranted. And so that can be the case when those costs associated with catching fish are very, very sensitive to having larger stocks of fish.
And so with your shrimp example, are institutions interested in sort of aligning when they allow fishing to improve that rate of return, or are fishers interested in that shifting? Are they interested in working together such they get a better rate of return?
Yeah, so that's a great question. And I've heard a number of speculations on that people in the industry, intuitively understand that collectively, if they could all trust each other and not go fishing as much early in the season, they'd all make more money. But the problem is there's many of them. They're geographically spread around, and they can't really monitor each other, or even they have no meaningful way to enforce. And so that becomes a real challenge for them.
Thank you, Martin.
Okay, we had a question that came through privately. Can you say more about the details of determining the financial value of a wider beach? Does value of real estate capture all benefits? For example, storm protection, increased attractiveness to tourists, etc.?
Yeah, so Satya is, I think, going to speak a lot about this. So I'll just say quickly, there are a whole host of values that include storm protection, amenity value of the wider beach. And of course, if you're a tourist, you might not care about storm protection because as long as it's not stormy when you're there. But if you own the property, you do care. And so there's some interesting differences there. But again, Satya is going to touch on this a lot in her talk.
Okay. And then Megan, are you able to unmute yourself and ask your question?
Sure. Scale is so critical in all these analyses you're talking about, right? Geographic scale, population scale. And I'm wondering if you can just talk some about how you define scale, right? Both in thinking about these rates of return and then also scale in the institutions that govern, right? You gestured toward it in talking about local decision making that's constrained by upper level decision making, but how do you think about defining scale?
Yeah, that's a great question. So in the scale of the individual problems, the modeling choices are complicated by, where do you draw the boundaries? So you might reach different conclusions about the beach nourishment rotation problem if you imagine a community in isolation in making this decision versus a community that's next to another one that influences that community and is influenced by that community. So I think that the answer to that part of the question is it really depends on whether those proximities to the other communities are of first order importance. And I think they sometimes are and they sometimes aren't. In the fish question, typically we gloss over what's happening in a lot of bioeconomic models. We gloss over what's happening within a season, but it turns out for something like shrimp, the temporal scale within the season ends up mattering tremendously in terms of the value that you generate. But then when you kind of hover outside and go sort of big picture from the governance scale, you have to ask questions like, what's the appropriate layer of governance for this system? Do individual communities in a decentralized manner making decisions, is that the appropriate layer? Should it be the state? Should it be chunks of communities? Should it be the federal government? And these are difficult questions. And of course, many of these problems are multi-scale in nature. So I did allude to it by mentioning Army Corps of Engineers and the sort of tension between the federal level and the local scale. But I don't think there's really a one size fits all for all of this. And Megan, you are far more expert in governance scale than I am, especially given your early work on water districts, which is a really a funky in between scale sort of governance.
Okay, we have time for one or maybe two really quick questions. So Don Kirkman, can you ask your question? Unmute yourself.
Can you hear me?
Yes.
I'm an economic developer, and my question relates to how different audiences experience different returns on investment and how you calculate that in determining kind of net benefits and costs. So in my example on beach nourishment, oceanfront owners derive certain benefits, non-oceanfront property owners derive other, probably less direct benefits, tourists have certain benefits, and yet the payment is, if it's being paid for by the federal government versus the state government versus local government versus the impacted property owners, it seems like every one of those users sees the rate of return and the return on the investment differently because they derive different levels of benefits and have greater or lesser levels of contribution to the solution.
So your question is a great one, and everything you said is absolutely correct. In a simplified, stylized model, right, you might sort of lump everybody together and try to understand some of the basic mechanisms that are at play in a problem like this. But if you want to go beyond that stylized mechanistic view, you need to start accounting for these things. And so one of the things you see, and Megan and I, and together with Dylan, have a paper on this that we talked briefly about a couple of 4 weeks ago. One of the things you see is some communities create these municipal tax districts where they actually tax oceanfront properties at a higher rate than the non-oceanfront properties. And they tax chunks of the coastline that are sort of heavy tourism areas more heavily than chunks that are more resident owners. And that's a direct response to the idea that people benefit differentially from these kinds of interventions. So that's an interesting, that raises a lot of interesting questions about the political process as well, because now you're taxing some people who aren't even really voting in those districts because they might be investors from other places that aren't registered to vote in the places that are making these decisions. So it's a great question, and you're absolutely on point.
Okay, so we're out of time for Q&A for Marty. Satya, if you want to get ready. I do want to mention that Reed had a second question about how realistic is the beach model, the logarithmic decrease of the beach width with time, and can it incorporate storm events? And I saw that Dylan posted a paper that everyone can take a look at within the chat.
Catherine, can you give me sharing rights?
Yeah, I can. Okay, you're now co-host. I'm gonna try again. And one more thing, in terms of references on the slide, we'll have suggested reading lists online.
All right. Well, thank you so much. Can everyone hear me?
Yes, I can. Yes, I can hear.
Yes.
Got it. So thanks a lot, Marty. This is a nice segue into thinking about the role of housing markets, in particular, in the way we think about these benefits. And I'm going to spend a good amount of time reflecting on some of the questions that have already been raised about how we value coastal amenities and coastal risks, and how those values are heterogeneous across locations. So let me start by just, the trends that we observe. This is a map that almost all of us, if we're interested in some form about coastal risk and coastal zones, must have seen at some point, that over the past 5 or 6 decades, we're seeing this systematic trend of populations moving towards the coast, right? And so 10% of the land area occupied by about 40% of the population, with the population density in coastal counties about 3 times the average population density in the US. Now, as economists, what we are interested in is we study human behavior, and by observing the decisions that people make, we are interested in inferring the types of trade-offs that they're making. So very similar to the ideas that Marty just went through, those decisions about where you put your money, or how you spend the budget that you have on housing versus other amenities or other expenditures, is what we're trying to back out from the observations of transactions or decisions that people make in the marketplace. So the way we do that is by looking at market transactions, and these decisions that we can observe by individuals give us information about how we value environmental amenities, environmental quality, and that information is revealed through market outcomes. So the prices that a property or the average home in Wrightsville Beach versus the average home further inland, or an average home in say Curie Beach that is not as well maintained, the differences in those prices that the housing market, the real estate market reflects differences in the environmental quality. So by observing those prices, we can say something about the trade-offs that people make in how much they're willing to pay to live on the coast versus, say, live a couple rows behind. And that's a difference that we can easily see in when we look at these housing market transactions. So housing markets and markets in general reveal information through the outcomes that we observe, the average price, the average wage in a labor market, for example. We also observe how people get involved, or how people's response through their behavior in the market. Where do people choose to buy a home, and what can we say about their preferences as well as their ability? So going where they choose to live, conditional on the budget or their income, that constrains their ability to participate in a market. So conditional on the ability to participate, the choice that people make, which we can observe based on the transactions that we're able to see, tell us something about how people might sort might go into different communities based on their preference for certain types of amenities, certain types of services. So some people may care, the population with kids care about school quality more than they care about, say, some other amenity. Coastal, you see retirement population moving towards the coast for a certain type of lifestyle or amenities from coastal recreational amenities and so on. So we see this through market outcomes, through people's behavior, and the way in which these markets respond to policy changes. Where we decide to invest in adaptation is then capitalized, then is reflected in the coastal real estate market to give us information on whether these adaptation investments are effective. Are they essentially reducing, at least are they reducing storm risk? Are they reducing perceived storm risks in the way that the consumers in the market respond to these to the policies, right? And it also, so this is all thinking about the demand for housing. There's also the supply of housing, right? Where do developers decide to build a new construction, and that reflects, again, participating in a market in a certain area, in a certain location, tells us something about the cost of development as well as the return on that investment for developing new homes. So I'm going to try and take one example from each of these types of behaviors to give a flavor for how we study coastal real estate markets in inferring how much we care and value what our value of environmental amenities is, and then how we can use those values to then think about how we invest in natural capital or make decisions about how can we maximize our return on natural capital, which Marty talked about. So the biggest market that we might getting engaged in as people move towards the coast is the housing market, and the housing market directly responds to changes in environmental quality, right? So Dylan might choose to buy a home in Wrightsville Beach because of the amenities or the ability to surf, which reflects his preference and the trade-off that he might be willing to make to live on the beach in Wrightsville versus somewhere else, right? And these coastal real estate markets also reflect risk. So it's not only the positive amenities that you get from environmental quality, it's also the storm damage, potentially storm risks that are also capitalized in the real estate market. So these dynamics of shoreline retreat, storm events, as well as the investments that we make in nourishment and building out the beach, all get capitalized into the housing market, which then influence the value of that natural capital that we're investing in. And so I'm going to talk about just one example from North Carolina, and the way we think about or how we use the data that we have or observations of housing market transactions to infer the value of environmental amenities, coastal amenities in the case of beaches, is that when you're shopping for a home, you're essentially buying a bundle of attributes, a bundle of services. So we can think about the price of a property, right? The price of an individual home in a beach J at a time T as a function of a number of different attributes. And so Z1 to Zn could be a variety of attributes, and we can decompose that market price that is observed when these transactions happen. We can decompose these attributes to infer these implicit prices, right? These betas that are implicit prices for attributes that together contribute to the value of that home. And when we, many of us have gone house shopping, we might think of about a number of criteria that factor into these decisions, right? How big the home is, how old it is there a garage, is there a basement? All of those are property attributes. So this is just the level to which that house provides housing services. That's one set of characteristics that influences price. Then there are the neighborhood level attributes, right? Is it in a good school district? Is it a safe neighborhood? And so we have neighborhood level effects that also influence price. And then we have environmental attributes. So when you go shop for a home, you're also choosing the level of environmental quality or the beach width, the view of the beach, or potentially risks from storms that come along with that location where you choose to live. And those values are capitalized in the price that you pay for a home, right? And so when we observe these prices and we observe the different attributes in each location, we can then estimate that implicit price for coastal amenities. And this example that I'm going to show from our work earlier in 2011 is looking at beach width. In North Carolina, we studied 10 beaches, and the ones that are red here were, at the time that we were doing the study, had never been nourished, and the ones in green had been nourished at least once during our study period, right? So we combine data that we observe, the prices at which the property sells, along with the number of property characteristics, with a suite of beach attributes, and then we estimate the impact, the implicit or the marginal effect of adding one more foot of beach to the coast on the property value, right? But then, if you recall from 2 weeks ago, there is this feedback that Brad talked about a couple of weeks ago. When we say that housing prices depend on a number of attributes, including beach width, if shoreline stabilization via beach renourishment is the policy that is in place and is actively being managed, then the beach width essentially is being controlled or is changing, and beach renourishment is likely to occur in places where the potential damage to property is high. So where there is a higher value of property at risk, you're likely to see more nourishment, which means the width is going to increase. So the housing price depends on beach width, but beach width via nourishment also depends on housing values, right? And if you recall, this was that feedback, both geophysical, which is driven by the erosion, as well as the economic feedback in terms of where we have nourishment happening, makes beach width, in this case, endogenous. It is endogenously determined or co-determined with the housing price itself. And so in order to recover an unbiased estimate of how much we care about beach width, or to what extent does the value of beach width affect housing values, we want to control for this endogeneity. And we do that by a method called instrumental variables. We use associated variables, right? And in this case, we were able to exploit the variation in coastal geomorphology. So this is an example of what economists, or I as an economist, would really have never thought of the distance to continental shelf as being a potential way to control for this endogenous relationship between beach width and property value. And what you can learn by working with geomorphologists is that this distance to the continental shelf is correlated or reflects the slope of the shoreline of the shore face, which then is a signal of erosivity of that coastline, or of the coastline in that location, right? So we're able to get geophysical characteristics of that location that are correlated with the beach width, right? Because it's going to affect erosivity, but are not directly affecting the property value, are not directly affecting what someone is willing to pay for that home, right? So that's what we call instrumental variables. So we're looking for things that are correlated with the variable of interest, with the factor that we care about, which is that amenity that you get from beach capital. And we're using that variation to predict what the width would be, and then use that to recover the value of beach width, right? And so we do this we use the distance to the continental shelf, as well as the probability of seeing a scarp on the beach. to instrument for this endogeneity. And then we're able to recover the value of beach width. And what we find then is that the real estate market or coastal property values are in fact a lot more sensitive to beach width than we had previously thought. If we ignore these feedbacks, we're underestimating the value that 1 foot of beach width adds to an average property in the study area. Now, what I showed you was sort of as if this were a linear relationship. It's not a linear relationship. You often estimate non-linear equations because of these feedbacks. And from this, we can specify a way of thinking about this estimation in the form of a logarithmic specification. If I look at log price as being something like in log and a baseline property value and beta times the width of the beach, I can estimate this equation, and where x is the beach width. And this gives me, the beta here gives me an elasticity of beach width. It gives me what is the proportional response in price when beach width goes up by, say, 1%, what is the percentage increase in price? And from this specification, I can get a benefit function, which is price is written in the form of ax to the beta. And this parameter here is that sensitivity, the elasticity of price relative to beach width that we can estimate empirically, and then use this, if you remember from the equation that Marty presented, this is that benefits function in stock form, which we can then convert into flows that is then used in the model of optimal beach renourishment. So we use this, we estimated beta, we took the estimated value of beach width with and without feedbacks, and then we then predicted the rate at which the frequency or the rotation, the nourishment interval at which these towns would be nourishing their beach. And what you see here, the white dots represent the predicted rate or the predicted time interval between beach renourishments when you account for the endogeneity of beach width, and the yellow dots show what that predicted rotation would be when you ignore the endogeneity. And essentially the way this is the 45-degree line. The closer these dots are to the dashed line, the closer observed and predicted nourishment intervals are. And should be fairly clear that when we're using these, when we're accounting for these feedbacks, we get much better predictions of how often these towns would be investing in renourishment, right? So we can, just to quickly recap, we have a way to get at how people who engage in the housing market reflect or are basically are revealing their preference and their willingness to pay for coastal amenities. Then we can use that to estimate a function which can then inform how often or how we can manage natural capital and how often we should be investing in maintaining or increasing that natural capital. A second way in which housing markets interact with human decisions is through policies, right? So what happens when we invest in nourishment? And I'm going to use the same example of the North Carolina coast, but now zoom in to Dare County and look specifically at three towns. And Nan said, which nourished for the first time in 2011. So we use this as a quasi-experiment. And so in 2011, there was the first nourishment, and then Hurricane Sandy hit, which did not directly hit North Carolina, but the effects were felt as far south as North Carolina. And so we have a town that did invest in nourishment and a town, Kitty Hawk, that did not invest in nourishment. And we then use, we know that these benefits are capitalized in housing values, and we can look at the trends in housing prices, the average sale price of homes over time in these two locations. So the solid line is Nag's Head and the dashed line is Kitty Hawk. And the first thing you notice is that these trends are fairly parallel. But then you have nourishment that happens around 2011. You have Hurricane Sandy that hits here. And then you see this difference in slope, that one town is being hit, or the prices are affected far more than the other, right? So we're able to estimate the impact of nourishment in terms of the risk mitigation. To what extent do homeowners perceive a lower storm risk because of the investment in beach renourishment, right? So it allows us, again, just looking at housing market transactions allows us to estimate those differences across towns that did and did not invest in natural capital, locally invest in natural capital. And then finally, we can think about, how do housing markets and how do people's behavior and where they choose to develop also reflect the information about risk and about environmental quality, right? So one of the things that we may have already, is if you might have seen the book on the geography of risk, and there have been a few recent papers that talk about building back bigger after a hurricane strike. The general thesis in this book by Gilbert Gall is that, over a century, if you look at coastal risk, the storms have been hitting for a long time, but the costs in terms of these billion-dollar hazards have increased over time, and that's because we're putting more people at risk because of this trend of people moving towards the coast and building more on the coast. So we ask this question of, does local adaptation via beach nourishment accelerate development? Are we creating this sort of maladaptive, we are having this unintended effect where investments or policies that are intended to mitigate risk might potentially increase storm risk exposure through the development process? So what we do there in this paper, which is ongoing work with a grad student and another colleague here at Ohio State, is we look at parcels that were not developed in 1991. We look at the timing of development over the past 15 years. When do people choose to develop an undeveloped parcel into a single family residence? We're looking only at single family residence in this particular study. And over the 15-year time period, we're estimating the likelihood that an undeveloped parcel will get developed at a particular time t during a given year. And these dots of different colors basically show you when a given parcel was developed in 5-year time spans. And just to illustrate that there is a good amount of heterogeneity in the timing of development along these counties, the southern counties in North Carolina. And what we find here is that beach renourishment increases the likelihood of development of a given parcel by about 27%. And this is again controlling for these endogenous nourishment effects and endogenous price in this case, right? So when you choose to develop a parcel, that it depends on the cost of development, but it also depends on the potential return on that investment, which is reflected in neighborhood level prices at which those houses can sell. But it's endogenous because once you develop that house, that price, that house contributes to that neighborhood price. So we've got to control for that endogeneity as well. And we do it in a similar manner by looking at different instruments that again are uncorrelated directly with the development decision, but are correlated with price. And we're able to control for these endogenous effects and find that beach nourishment increases the likelihood of development, controlling for erosion and storms and other geophysical as well as economic factors. So then we can take this model and we can use it to predict development. So first we can test our model by looking at the rate of development, the number of parcels that have been developed in any given year over our study period. And what we find is that our model really almost perfectly predicts the number of parcels that are developed in any given year, although there is some heterogeneity by location. So it's not a perfect prediction of every individual parcel, but it predicts really well in aggregate how many parcels would be developed in a given year. And once we're fairly confident that this model reflects or fits our data well, we can then use this to simulate policy scenarios of, for example, what would have happened if there were no nourishment. If there weren't any nourishment projects, what would the level of development have been during that same time period? So we can use that and to predict what or hypothetical policy changes or hypothetical geophysical changes might do to the rate of housing supply in the market. And what we find here is that, and this is just a snapshot of the way in which we simulate which parcels would have been developed or not developed over the time period. And we find that the predicted development is about 21% lower without nourishment relative to the status quo or the data prediction without any policy simulation. So this suggests the sort of development paradox that many of us here who are working with the Seacoast Group are quite interested in, is in are we investing in risk mitigation in a way that potentially increases risk exposure? And if that is true, if it accelerates development, when do we stop? What is the optimal level of risk that we can put on the coast, and how can we simultaneously think about the rate of development and the risk that we're adding, and the rate at which we should be investing in this beach capital, or the rate at which we should be investing in maintaining the shoreline. And that's some of the ongoing and future work that we're interested in. So I'll stop with that and take questions. I think I'm doing okay on time. So over to you, Catherine.
Okay, can you unmute? Perfect. Okay, Q&A. I saw that there was a question from Matthew. Can you unmute yourself?
Sure. Hi, Satya. My question was this, I guess this relates more to the first part of your presentation, but I guess it also connects to the use of property values and the development you're looking at in response to nourishment after. I was wondering if you could talk a bit about just the use of property values more broadly as like a measure of these types of value. It seems to me that when you use property values, you're mainly only accounting for the value of people who are somehow in the market for beachfront property, and thinking about the value of both nourishment and preventative measures against sea level rise. The values that would be relevant on like a social level on larger scale would be much larger than anyone who's able to purchase property or is somehow connected to this market. Yeah, I was wondering if you could talk about that a bit.
Yes, and you're exactly right that the real estate market, or the way in which we can infer property values through, say, a hedonic equation, only reflects, it partly captures the value, and it captures the value for people who are living on the coast, who are making that decision to invest, or in other words, it captures the value of the coastal amenity and coastal risk that gets capitalized into the real estate market. Now, in order to think about the value of other values on the coast, there are parallel, or there are analogous methods in which we would think about, how much are people willing to pay to actually go to the beach. So there are what are called travel cost methods, which is, you ask people how much they are willing to pay to take a trip to the beach, and that gets at certain types of day visits and certain other values that also get picked up in the way people make decisions. So there's recreational value, and there are a few other methods that we could use there. But the real estate market does, to a large extent, capture some of that in space. The risk at the value that is capitalized in location, or in that space, if that makes sense. So ideally, to think about how much the entire beach is worth, you would want to add the value that is reflected in capital stock, as well as some of the recreational benefits from day trips that people might take.
Can I just add one other thing to that, which something that's really interesting about this problem is to what extent kind of future recreation that might actually rent a beach house or something, to what extent is that reflected in the current market? And I guess that's a question about how well to investors in these markets, how much do they consider that and anticipate that future tourism market? So I don't think there's a clear answer to that, but I just wanted to put that in there.
Okay, we had
That's
another
great.
question from Reed. Reed, can you pick one?
Yeah, just one? All right. I'll pick the property values and nourishment. So you showed that relationship, 1 foot increase of beach value or beachfront adds that value. I'm curious if that is just a relationship with front row homes. If not, how far back in a beach community does that actually go? And can you measure that with the data that you have?
Yes, and I didn't have a chance to get into that detail, so thanks a lot for asking this question. So among the things that we would control for is the distance to the shoreline or to the ocean front itself, and we're able to look at how much we could interact, how far you are from the beach with the beach width. So as you go farther away from the beach, the value that you add, or the additional value that incremental width gives, is attritioning or continues to decay as you go farther and farther away. And in our study, we found that it actually drops off somewhere around the 300 meter. It goes to zero. So if you go a few rows back, the value of additional beach width literally goes to zero the further inland you go, beyond like about 300 meters in our data. And that graph that I showed was actually looking at oceanfront. What is the value add for oceanfront?
So as a follow-up, should anybody beyond 300 meters from the shoreline help pay for the nourishment?
I think that goes back to Marty's thing about municipal tax districts, right? The difference is actually quite high in places like Nags Head. I think the beach nourishment tax that is placed is almost is double relative to any house that is not in the municipal tax district, and that tax district is literally the first 2 rows, and that's where you're getting that extra. Where you're contributing more in terms of local taxes, to the extent that local funding that nourishment is locally funded. Now there's federal subsidies as well, which is less direct. But the homes that are farther away are still getting benefits in terms of access to the beach, which is not quite what this marginal effect captures.
Okay, so we had one question that came in right before you started talking, and Satya, I think you could probably comment on this. Taylor, are you still here? Can you unmute yourself and ask your question?
Yeah, can you hear me?
Yes.
Mm-hmm.
Yeah, so it was a bit of a rambling thought that was going through my head as Marty was talking. Basically, I was trying to understand how the problem of as things are done at an institutional level, Marty talked about a lot of advantages that come out of this, but I venture to guess that there are probably some added costs to that. And I just, guessing what some of them might be, obviously there may be added labor involved, but more substantial might be things like increased level of detachment from the problem at hand, or loss of familiarity with the problem. And I wondered if it's even possible to model those and quantify them, and if so, how it's done.
Is this about the fishing? I'm going to let Marty answer that.
Yeah, I think your question is about what's the right institutional layer, like how local versus how centralized decision making should be.
Exactly. Yeah. I was trying to think about how you optimize.
I think that's a huge question. That's really it gets into this literature on environmental federalism, but it also is a big issue in community-based environmental management, where People who promote that style of management, one of the big benefits, of course, is that people are locally very invested and familiar. But of course, you can't just draw lines in the sand and decide that what you're doing locally has no effects that extend beyond your local area. And that's, some of the large scale modeling of coastlines that Brad Murray does, and, speaks to that. And similarly, the work that Laura Mora does on sort of the dune building, you think about what's going on locally, like in the, you're bulldozing the sand off of these places, and you're going to let people do that, but then you're sort of building up this intense vulnerability over time and fixing the shoreline in place. And that's really kind of feeding back to what Satya is talking about, that you're encouraging this development. And it's hard not to say that's at least partly attributable to the local nature of decision making. So yeah, but I think it's a hugely complicated trade-off. It's a very hard question.
Thank you.
There was one question from Matthew, I think, about non-use values, and I think I'll just quickly respond to that, where I should have probably mentioned this earlier, that all of these methods, which are really using revealed behavior in markets to get at how much we might care about or how much we would value environmental amenities, environmental risks, are only going to capture use values. And you're exactly right about that. And there are a suite of other valuation methods where you could go ask people how much they would be willing to pay to make sure the beach is protected for future generations, which then suggests that if we ignore non-use values, yes, this is a lower bound estimate, but these lower bound estimates are high enough to really push policies to maintain the shoreline. So just acknowledging, yes, this is a use value that is being estimated here.
Okay, we have to stop the Q&A. Dawn, that's a really good question. We'll try to follow up with you or comment. So really quickly, next time we'll be talking about, or David Eggleston and Janet Nye will be talking about the ecological concepts to guide oyster restoration and climate and fisheries ecology. So we hope you will join us. Thanks for coming.
Thank you.
Thank you. It's been great.
Thanks, everyone.